So if I have cosine and cosecant, yesterday I think I mentioned that your goal when you're doing these is to change everything to sine and cosine. Well, this guy's already cosine, so he's good, right? Cosecant is 1 over sine. So this is going to be the same as cosine times 1 over sine of theta, okay? Which is cosine of theta over sine of theta. And if you look at your paper, now that you've finished it and it's gotten down to one fraction, cosine over sine is the same as cotangent of theta. So that is the most simple way of writing cosine of theta times cosecant of theta. If you notice, the tan squared of theta plus 1 equals secant squared of theta, right? That is a rule that's on your sheet in the Pythagorean identities. Tan squared of theta plus 1 equals secant squared of theta. So I need to get it to where it says tan squared of theta minus secant squared of theta. So if I move this guy over here, I have tan squared of theta minus secant squared of theta. And then I move the 1 over here as a -1. Does everybody see that? Mm-hmm. So technically this is the same as -1. So it's 3 times -1, which is 3. So 3 times -1 is -3, and that is your answer, not +3. So cosine squared of theta plus sine squared of theta is 1. If you subtract sine squared of theta from the 1, you get 1 minus sine squared of theta equals cosine squared of theta. So cosine squared of theta over sine squared of theta equals, and cosine over sine is cotangent. It's up at the top, and since they're both squared, it's cotangent squared of theta. So let's look at this. We have tangent. Tangent squared is sine squared of theta over cosine squared of theta. Because you look at your Pythagorean triples and there's nothing with a sine and a tangent in it, so you know you have to go to plan B. Over sine squared of theta over 1 over sine squared of theta over cosine squared of theta times sine squared of theta over 1.